Hey, what's up guys? My name is Cherno. Welcome back to my game engine series. So last time we took a look at precompiled headers, definitely check out that video if you haven't already. And today we're going to be finally creating a window so that we can render stuff onto our window. So I was really contemplating when to do this in this whole game engine series because, I mean, technically speaking, I probably would have done a lot of stuff before I even considered adding a window. If I was just making a game engine in my own time, as kind of a software engineer, I would make sure that I had a lot of stuff already done before I kind of just made the window. Making the window and kind of doing all of that graphic stuff is what a lot of people do as their first kind of steps. As you kind of learn more though, and as you get more familiar with what kind of a game engine, how a game engine is actually architectured and what that looks like, it becomes apparent that there's so much more than a window. And whilst adding a window is useful because you can like render text and display debug information and visualize things actually working in your game engine, as well as the fact that, you know, games typically render graphics and that's kind of important. Once you kind of, if you put that aside, there's actually a lot of stuff to a game engine, like the event system, like the application system, like a layer stack system, like, I don't know, input managers, all of that stuff that actually has to be done potentially long before you have a window. So I've kind of made this decision to actually make a window now though, because I feel like a lot of people are beginning to maybe lose a bit of interest, and I have to kind of, in this whole game engine series, I have to actually remember that I'm not just a software engineer building a game engine, I'm actually also trying to teach and also trying to be somewhat entertaining so that people are actually enjoying these videos. And so because of that, there are kind of compromises that I make, and we talked a lot about this during the partner hangout, by the way. If you guys aren't aware, you can support me on patreon.com/thecherno, and if you pledge a certain tier, you actually get invited to a partner hangout that we have once a month, where we actually just have a video chat with all of the other partners. Partner is a tier of Patreon support on my Patreon. We actually have a discussion about where this series is going and how to do things, and this actually came up, I think, in the last month partner hangout in November. So definitely check that out if you're interested. But I have to make compromises because I have to compromise between entertainment, education, and software engineering. But anyway, I've decided to make a window kind of now. I think now is a good point. We at least have logging and we have events. That stuff is like a must in my opinion before you make a window, because I mean, it doesn't really matter, you can make your window first and then make the other systems, but they go hand in hand. You need logging because you need to see what's happening if things go wrong. And as you're kind of running your window class, it's nice to be able to insert logging and like assertions and stuff. We'll actually talk about assertions loosely today as well. But you also want events because a window is very tightly tied with events. And we're just going to take a look at actually implementing kind of a window class today in an abstract way, because remember, we want to support multiple platforms and the implementation of windows on those other platforms will actually kind of differ. So we want an abstract representation of a window, which we'll talk about today. And then also, you know, stuff like events, I think we'll cover in the next episode, where we can actually hook up our window system to all of our events and just have that kind of work correctly. So let's talk about the technology that we're going to use a little bit. So I'm going to use a library called GLFW. I have an OpenGL series and I have a video about GLFW, which will probably be more detailed than today's video. I'm going to assume that you guys kind of know how to use that. GLFW is a very, very simple kind of cross-platform, meaning like Windows, Mac, Linux. I think they support maybe other platforms as well. But it's just a really easy way to kind of create a window using your relevant platform API. I don't really want to take too much time to actually use the Win32 API to create a window, just because not what this series is really about. We might eventually have to, because, you know, GLFW, for example, doesn't actually support DirectX, right? We definitely want to support DirectX and Hazel at some point, because that's my preferred rendering platform on Windows, and it should be everyone's preferred rendering API on Windows, because it's made by Microsoft for Windows, so obviously it's going to be better than any other API when you're running on Windows. That being said, I do want to get something up and running, and I think I mentioned that we're going to stick to OpenGL in the beginning just so that we can get stuff as quickly as possible. So because of that, we have kind of a dilemma. So I don't want to waste time now writing Win32 API code, but we might have to in the future. And also GLFW is something that's available on multiple platforms. So immediately we kind of have to think about, well, where does the abstraction lie? What I've chosen to do is to implement a window class per platform. Now you might be like, well, hang on, if you're using GLFW, isn't the implementation going to be largely the same on Windows, Mac, and Linux? Well, yes, initially it probably will be, or it will be similar. Maybe there's some slight differences, some stuff that we might want to add that's on Windows only, for example, or that might differ on other platforms. But GLFW-wise, of course, it's going to be the same because GLFW is that abstraction away into the other kind of platforms. So I'm still going to make a separate window class per platform. However, and I think this is the first time we're actually abstracting stuff, so we'll talk about that as well. However, in the future, we might be like, you know what, GLFW on Windows, I'm dropping that because we're actually going to switch to using Win32 API because we need to make a DirectX context and all of that. I mean, we could modify GLFW potentially to do that, or we could just get the required Win32 like HWind handles and stuff like that, and like the device handles, the device context handles from GLFW, which it uses to create the Windows window using the Win32 API anyway, and then from there we would have our necessary handles that we need to actually create a DirectX context, but I haven't decided yet. But the point is, there's definitely going to be a point where we do Windows only Windows creation code and all that stuff, right? So we definitely want a Windows kind of window, even though we're using GLFW, which is cross-platform. So hopefully that makes sense. I've also forked GLFW into my own GitHub repository. It's public. It's just the Cherno. It's github.com/thecherno/GLFW. We'll use it here in a minute. I've just added premake to it. It's just a really quick premake file that only works on Windows for now. I'll probably update that in the future to support more platforms as well. But there's just an easy way to integrate GLFW with our premake build while still having GLFW, all of its source code in our Visual Studio solution and all of that. And then just link it kind of project-wise. So that's what I've done as well. I think we can probably talk about just the notion of platform abstraction and how that works. I'll probably make a video dedicated to that because today I just want to get a window up and running, and if I start talking about this, it's going to end up taking up the whole episode. But essentially what I've done is I've made a platform folder, which is for platform-specific code, and then I've made a Windows folder, which is for Windows code, right? We'll also have, eventually a Mac and Linux folder, and maybe if we support mobile platforms, Android, iOS, that kind of stuff. And in the platform folder will also lie our rendering API-specific code, such as OpenGL, DirectX, Vulkan, Metal, that kind of stuff will also have its own folder there. We might even have a POSIX folder that's just kind of for, Mac and Linux related and Android related kind of code if it ends up being the same. But that's kind of the idea. That's all you need to know about platform abstraction now. Let's go ahead and add the GLFW repository that I've forked as a submodule now so that we can actually get it into our project. Okay, so what I have here is, as you can see, the Cherno/GLFW. I've just forked it from GLFW a while ago, I think, because you can see it's 11 commits behind master. But it's just forked from GLFW master, and then all I've done is I've added this, and it was actually 28 days ago, wow, 4 weeks ago. I added this premake, so you can see how far ahead the Hazel dev repository is, which patrons get access to, because I did this actually like 4 weeks ago. But anyway, this premake 5 Lua file, very simple, right? It's 45 lines of code. All this does is just for Windows, essentially, for now. Indentation, I think, is a bit wrong, but anyway. This stuff doesn't even work, and this needs to be updated to latest, and there's a few things that need to be done actually. I thought I pushed that, but I didn't. So yeah, the indentation is horrible, but anyway, you can see it includes all the relevant files here under filter Windows. These are all the platform agnostic, kind of platform independent files. These are the Windows only files, and then it's got defines as well, and all of that stuff. Really simple stuff, nothing really to it. We're going to clone this as a submodule because this includes our premake file as well as all of GLFW. So on our command prompt in cdev hazel, which is our kind of repository root, I'm just going to type in git submodule add. I want to add this GLFW submodule, and I want to add it to hazel /vendor/GLFW. Okay, and it's going to clone this whole repository into that directory. And then if we kind of boot this up, we should see inside vendor, we now have GLFW, okay? And that has our version of GLFW along with that premake file. So now what we want to do is actually add it to our premake file. And I've already done that, so I will just show you the diff. In fact, we'll just do a git, we'll do a diff tool diff. Okay, so this is all of it. Let's look at the pre-make 5 file. So this is what I've done to the pre-make file. I actually ended up creating basically a struct, a Lua table, which is going to be a list of include directories that we have that aren't ours. Now these are important because we want to obviously have GLFW's include directory, in Hazel, so that we can just use glfw/glfw3.h, which we'll have to include. So I'm setting a compiler include directory, but I've just put it into its own kind of struct here, into its own table, because this will grow obviously to include each dependency. This include here actually includes that pre-make file that we have. So this pre-make file, we just looked at this. This directory is Hazel vendor GLFW, okay? I'm including this, which what this will do is include that pre-make 5 file into here. So basically, this is almost like a C++ style include where this, if we look at this in Visual Studio, this kind of gets copied and pasted into our pre-make 5 file, right? So inside our pre-make file, we now have another project called GLFW. You can see this does not have workspace or anything like that. It doesn't have workspace. GLFW, it doesn't have a solution. It's just a project. It's just an additional project which compiles as a static library, outputs into the same directory, and it just includes a bunch of files. Okay, that's all it is. We've just added another project. And then the important thing is once we have that project, we're actually going to link it, right, to our Hazel project. So Hazel is now dependent on GLFW. Hazel is a shared library, meaning it's a DLL file. So of course we can just include a static library into it, right? Or link rather a static library into it. Really need to fix up this indentation. I did not know it was so bad. This is what happens when you don't. Let's look at this for a minute and let's go to view. Where is this? I think it's in view. No, edit, advanced, and view white space, just so we can see what on earth is going on. So you can see this is tabs and this is spaces. That's why it's messing up. So I'm just going to convert all of this to spaces, and this should make everything a lot better because clearly we're mostly using spaces in this file. I think that's no. This is a tab as well. Okay, and so is this stuff. So this is quite useful if you want to fix stuff up like this. Okay, we can get rid of that. Okay, brilliant. So now if we refresh this, everything should be better. It's not though. This is on the diff tool. Wow, it's made a temporary for some reason. So let's just rerun diff tool. And we should see this is now perfect, but it's clearly not. Is this the right file? Oh, it's in GLFW. Whoops. Okay, so we fixed the GLFW one. Let's fix our one as well. Because this is apparently a mess. Oh, wow. So this is mostly tabs. I see. In fact, this is all tabs. Okay, this is spaces though. Wow. Okay, we need to really stick to tabs or spaces and not use both. Because this is a bit of a drag. Anyway, I think that should be good. We've got tabs everywhere now. Okay, so does that fix it? Or do we have to restart this again? Because it is in a temporary directory. And there we go. Good, it's good now. Okay, so back to this. So we're linking GLFW, which is that project that we've just included, okay? Now this include directory just needs to get added as a compiler include directory, which is what we've done here. In our include directories, we've added include directory.glfw, which means that Hazel vendor GLFW include is now a compiler include directory, okay? And that's all the changes that I've made. So literally include that pre-make file and then just set the include directory and the link. We're also linking OpenGL32.lib because we need that. That's all that I've done, okay? Now let's take a look at some of the new files that I've added. Actually, well, first thing, let's just run pre-make because I haven't even ran pre-make yet. So we'll do generate projects and then hopefully this will do all that. You can see it's generated that GLFW project. If we go back to Visual Studio, reload the solution, we should see GLFW here, and you should see that Hazel actually references GLFW. Okay, beautiful. Let's try and compile that in debug x64. Hopefully this compiles successfully. I haven't actually done this. Okay, so there's some unknown options. I'll clean that up in the GLFW thing. I don't know, this is just trying to use C11, but obviously this is not for Visual Studio's compiler because of the way that it's linking. This is more or less for probably Clang or GCC would probably both accept this. But obviously, there's a different syntax for command line arguments in the MSVC compiler. Anyway, one succeeded is just ignoring those, so it's fine. And we've now built GLFW. You can see how easy that was. So I love pre-make because it's so nice and easy to use. Okay, so next step, let's take a look at some of the window classes that I've made. So inside Hazel, just inside Hazel, you can see there's a platform folder as well. But inside Hazel itself, I have this window class now. And this is an abstract representation of a window, okay? So this is platform independent. This is what our application uses. I haven't written it yet. I'll write it in front of you guys. So application hasn't been modified yet. But we're basically going to use this window, okay? And you can see what it has. Now it's got an event callback function, which we'll talk about in the next episode. A virtual destructor, and then it's mostly, as you can see, pretty much it's all actually just an interface. Right? All of these are pure virtual methods. There's no data in this class at all, and there's no functions in this class at all. Just pure virtual stuff, right? Because this has to be implemented per platform. So I've just made an interface, okay? A desktop system, of course, because mobile apps, for example, don't really have a window. They more or less have like a surface. Okay, so that's that, okay? Kind of basic, not much. We'll add stuff to it as we go, but that's just what it is. And then this, I just have some basic window properties which you can specify over here. Now, because this is kind of platform independent, we have this create function, which actually has to be implemented per platform. So this is not, there's no window.cpp file, there's just a window file, just a header file, and then this gets implemented per platform, because obviously this creation function should return, for example, Windows window if we're compiling on Windows, or Mac window, or Linux window, or whatever we decide to call it, depending on what platform we're actually compiling on. There's no need to, for example, have a platform independent one, which, you know, has a switch statement, which includes, this is all decided at compile time anyway. We're not going to be compiling Mac code on Windows or vice versa. Properties, title with height, that's all we've got for now. Default parameters here as well. Hazel Engine is the default title if you don't specify one, and then 1280 by 720 is the default width and height. And then you can see we have, if you don't specify Windows properties, it creates the default, which is this. Okay, that's that. Now inside platform, inside Windows, we have Windows window and the CPP file as well. Okay, this is pretty simple. This is just an implementation of everything. Okay, so some of this stuff actually really should be marked as override. I don't know why it's not. So let's see what it actually inherits. So vsync and then event callback with height and on update. So that's all set. I just missed these two apparently. Okay, okay, so the way that this is primarily implemented is we have a struct of window data. You'll see why we have this, because we need to pass it into GLFW, but that's more or less for events, which we'll talk about next time anyway. But basically, this is where we store all of our actual data that might be requested by GLFW during event callbacks. And then we just have a struct. This way we can pass just the struct to GLFW as like custom user data, and we don't have to pass this entire class. Not that it matters too much, but this just keeps all of our kind of Windows-specific data grouped nicely here, which I kind of like. We have init and shutdown, which is two kind of functions that we've created. On update, we'll just kind of should just update GLFW, swap the buffers, poll the input events, all that kind of stuff. It should be run like once per frame, and called from our application. We'll call that in a minute. Everything else I think is pretty straightforward. Let's pop over to the implementation. So here's the implementation of that creation function that we had in Windows. So in Windows we had this create function. This actually gets implemented in a platform specific file. So in this case, it's implemented, you can see it's window create, not Windows window create, just window create and returns a new Windows window. Okay, that's it. Pretty simple. It just returns a pointer. Okay, we'll store this pointer in probably a unique pointer in the actual application class. Okay, so in the initialization, destructor does nothing for now. This just calls init. The reason I haven't done anything in the destructor yet is because we don't necessarily need to. We can destroy the window actually. I think GLFW destroy window. We should do that in shutdown. Let's just add that code right now. Shutdown. We can do that, but we don't want to necessarily shut down GLFW because we might need it. Like we might have more than one window. That's also why I have this static here, because we only want to initialize GLFW once when we initialize our window, but we might create multiple windows. So yeah, but if it hasn't been initialized yet, we'll initialize it. So that's essentially what init does. When we create this window, it calls the constructor, which calls init, sets up all of our data based on the properties, logs some stuff that we might want to see, initializes GLFW if it hasn't yet, and then let's talk about this core assert, because that's new. Inside core.h, I've added assertions if we enable them. Okay, we should add that to the pre-make file for debug, probably. Probably not released. What this does is basically it says it checks a certain condition and then logs a message if it fails, and also it's Windows only for now, just calls debug break, which basically just is like inserting a breakpoint at that line of code so that it just breaks the debugger on this actual line of code. Okay, so that if an assertion fails, we can see what has gone wrong. Okay, so for example, in this case, we're using it here to check to see if this has worked out. So if this is something that gets removed in runtime, in like release builds, for example, or distribution builds, that's why I didn't write this code like this, for example, because if that happened, then GLFW would not be initialized at all in release builds, which is not what we want. We still want it to be initialized, but we're just checking the condition only in debug builds. We might add something called verify instead of assert, which basically is the same as an assert, except it doesn't strip the condition. So it basically does that instead. The reason is that because this compiles to nothing at all in like certain configurations, if enable assertions is off, we can run functions that we wouldn't otherwise run at all just to verify stuff. So it's quite useful. And assertions are just something that we'll be using a lot of. I love using them. It's just a quick way to verify that your state is correct. And you don't have to worry about wasting performance when you do that because they get stripped from release builds. We GLFW create window. Again, that GLFW video in my OpenGL series will probably explain more about this. But we basically just create a GLFW window, make the context current, and set a window user pointer. Now, this is something that we'll use in our event callbacks for mdata, because but the way the GLFW works is that we just set certain event callbacks. For example, GLFW set, key callback. And this is just a callback function that we specify that will get called whenever we press a key. This means that we are passing this struct of data, or a pointer to this struct of data, into that callback function, so that we can, for example, be like, I can call that event callback function if a key is pressed, or if the window size changes, I can set this width and height and also call the callback. So that's kind of what we set this for. And then vsync, we've just set to true because there's no reason really for it to be off. Shutdown destroys the window, we just added that now. Update will just poll the events and swap the buffers. And then we have a set vsync function, which if we decide to enable a vsync, sets the swap interval to 1. This doesn't necessarily have to be 1. 1 just means it'll wait for like 1 frame to be called, 1 frame to be rendered before it starts like the next thing. Whereas 0 means nothing. So that's what we've done for now. Again, I imagine once we replace this with Win32 code, might do something a bit different, but that's just a basic implementation of vsync. And then we keep track of whether or not it's enabled, because we can't actually retrieve that data from GLFW. And then we have an isVsync function which returns whether or not that is switched on. Okay, that's it. That's our window. Really simple stuff. Let's add this to our application now. So what I'm going to do is inside application, again, this is platform independent, I'm going to create a unique pointer, which is going to hold an instance of the window class. Unique because obviously only this class owns it. This will be just window.h. So we have a unique pointer of window. And then all we do is in the constructor, we'll set this to be, we're not going to make unique or anything. It's just going to be window create window, or window create. And we'll specify probably no properties. Now, because this is an explicit constructor, we actually have to type unique pointer here. and then do window create like that to create it. Okay, cool. So we've got that. We've got our unique pointer, means we don't have to delete the window ourselves when the application terminates. Application obviously is kind of a singleton, meaning we only have one application for our entire application. So this is definitely fine. Okay, we'll get rid of all this kind of event testing for now. And then inside here, I'm actually going to make a bool here called running, which we'll probably set to true to begin with. We can just initialize it here. So while this is running, we're going to update our window by calling mwindow on update. And I mean, we could just chuck in some OpenGL code here to test it in a minute, but that should be all we need to do really, because window create will call the constructor, which will call init, which will actually initialize GLFW and create our window. So that actually should be good. So if we hit F5 or the play button here just to actually debug our code, we'll see what happens. And this is obviously building and linking GLFW for the first time, so hopefully everything works out. Okay, check that out. So we have Hazel Engine here. Over here it says that we've created a window, which is our Hazel Engine. I might just get rid of this app hello. Oh, maybe we can keep it there because it's testing client-side logging. But yeah, create a window, Hazel Engine, 1280 by 720. You can see it's there. We can't close it or anything because we're not handling events yet. That will be in the next episode, but we have this. Awesome. And we should also have an OpenGL context. So what we should be able to do is, for now, I'll be naughty and include GLFW3 in this file. And I'll just do something like GL clear color 1011, which is pink or magenta, and then we'll just call GL clear on the color buffer bit. Okay, let's see if this works. We should get a pink window here. Awesome. There you go. Okay, so we have now a window finally and an OpenGL context. No events yet, so we want to, the next step kind of where I would go from here is to actually make it so that key events and mouse events and window events like closing and resizing and all of that fun stuff is actually propagated to this application class. So essentially what we want to have is a function here which is like onEvent, right? An onEvent function, which when we call, which we will kind of call from the window class, but we obviously don't want the window class to be aware of application at all. It should be completely modular and kind of out to the side, should not depend on application at all, which is why we have this set event callback function, which will just kind of call from the application to notify the window, hey, all the events, please call them back into here, and then we can propagate them to all of our layers, and that is how this engine will basically deal with events of any kind, including window events. So next time we'll implement that. I'm really excited about that. I think if we just look at the diff, I don't think I've missed anything. The only other stuff I did, I modified the PCH. Oh yeah, I added the log to the PCH file because log is not going to change, and this is something we want in pretty much every file. Core.h, I added the assertions as I mentioned earlier, and that's it. So I didn't modify much. The big thing was obviously GLFW. So that is it. Okay, so that's our window class. I hope you guys enjoyed this video. If you did, you can hit the like button. You can also help support this series by going to patreon.com/the Cherno. Huge thank you as always to all the patrons that make this series possible. Next time, we're going to be implementing events into our window class. I'm really excited about that because that'll be cool. We'll actually be able to like move the mouse and see where the mouse position is. And then from there, we can probably get onto rendering graphics of some kind, and probably before that though, setting up like a layer system, and we can get onto more kind of engine architecture kind of stuff as well. But now we have a graphics context where we can draw things onto. So we'll probably add IMGUI to that pretty quickly so that we can actually start seeing like, you know, a visual representation of things, and actually just have more data available to us that might be a bit awkward or just annoying to log. So yeah, that's the plan. Hope you guys are excited for that. I'll see you next time. Goodbye.